Keep quiet. Shh. Shh. You're making too much noise. Wait, that's me. All right. There you go, Nick. It's all yours.
Oh, yeah, I'll get some light. Oh, yeah, we have some tea in the make. I can grab some coffee. Yeah, you guys know tech systems.
No, come on. You gotta come over a real spiel.
I'll help you out here. Welcome to PowerShell Saturday for, what is this, June?
PowerShell Saturday?
Saturday, excuse me. Tuesday in June 5th. And our guest speaker tonight is Tim Warner from Tennessee, Nashville, Tennessee. And I would really like to thank our sponsor, Tech Systems, and our wonderful videographer, audio nerd, Mr. Oliver.
Thank you.
So with that, I'll hand over the floor to Tech Systems.
Cool. Won't take it too long. Don't want to waste your guys' time too much. I'm pretty familiar with most of you. Tech Systems is the nation's leading IT staffing and services provider. We can help with contract work, direct placement work, contract to hire, even something as simple as helping you update your resume, going over some interview preparation that we're not involved with. You know, I want you guys to do well and succeed in what roles you're going for and everything like that. So even if it has nothing to do with us at all, I'd still love to help you guys out. 110 offices across the nation. So any buddies of yours that you used to work with or have moved that are looking, could definitely connect them with one of us, and I can connect them with a local point of contact for them. We're working with Wells Fargo pretty heavily here in the Valley, APS as well. We are also going to be working with Silicon Valley Bank, Bank of the West, GoDaddy, Expedia. So a few Fortune 500 companies here that we're working with. So nice. Send it on back to Tom. You guys love PowerShell, support the whole thing, so you guys just have at it.
Cool. So this is where I put your LinkedIn profile, right? So
sure. Yeah. You want my Facebook profile?
Yeah.
Instagram, I'll get it all. Yeah. But cool.
Thank you. Thank you.
Okay, Tim. Since I'm remote, you can't see nothing but my ugly face, so I guess the floor would be yours, my friend.
Thanks a lot, Tom. I have two questions. Number one, is my audio coming through okay?
Oh, it's coming through very well. Thank you.
Great. Glad to hear that. Number two, can you see my PowerPoint slide? I'm sharing my desktop.
Yes, we can see it.
Wow, good. Rock and roll. Yeah, because it being 8 p.m., I'm home, so I'm not in my office, so I'm just working off my laptop's built-in webcam and mic. I'm glad that it's okay. Well, thanks very much for inviting me to AZPosh. Tom, Oliver, thank you both very much. As I was preparing this presentation for you, I don't know, I went through a little confidence dip there for a while. I thought, what can I possibly teach these people? And I made the mistake of asking Jeff Hicks, who some of you, probably most of you know. I have access to him every day because he's a fellow Pluralsight author. And I just shared these things with him, not really knowing what to expect. I was like, Jeff, I'm feeling some low confidence, blah, blah, blah. And he said, Tim, pull on your big boy pants and make it happen. And that's one of the things I love about the PowerShell community. You're going to get very few people blowing smoke up your butt, which I appreciate. They're going to tell it like it is. And that's what we're going to do. We're going to make it happen. Tonight is about protecting credentials in PowerShell scripts. And here's the agenda that I put together for us. First, we'll look at what we don't want to do with credentials in PowerShell code. Then I've put together 5 options, kind of in ascending order of complexity. But of course, as you know, I'm sure that the more secure you get, there's a trade-off of usability to an extent. So we'll start with interactive authentication, then saving your credential, your password to a file in various formats. Then we'll look at a couple select community modules that address this pain point. Option 4 is REST APIs and Credential Vaults, and then only if we have time, and because it's a favorite subject of mine, we can look at PowerShell credentials and running PowerShell code in Azure Automation. So that's what we have. As we go along, any questions, stories, concerns, anything that you have, just please stop me in my tracks and we'll address it, because that's why I'm here, to talk shop with y'all. Now, the session materials, this PowerPoint deck, as well as the PowerShell script file that I'm using for demos tonight, can be found at this URI, timw.info AZPosh1. So that will give you a zip file that contains the PS1 file. And I don't share my PowerPoint source, I make a PDF. That's the next best thing, I would say. And I'll put this address up at the end of the presentation as well. All right, so starting off, let's look at what we don't want to do with credentials before we review the major possibilities for protecting them properly. This is a pattern that you're all probably familiar with, where we're revealing the password in plain text in our source code, and then we're pipelining that into convert to secure string to create a secure string object. And you know, with as plain text force, you can kind of shoehorn the plain text credential into an appropriate format after all. You see in the last part of this code, we're building a PS credential object. The credential object, as you know, I'm sure, has two properties: the username property that's a simple string, and a secure string that represents the encrypted password. So that's encrypted in memory in your current PowerShell run space. Why is that a bad idea? Well, if you go to GitHub and just do some searches, you can find quite a few, well, maybe not quite a few projects that use this pattern, but you're bound to find it. Or if you go to Shodan or another of those sites that scrapes the web for juicy tidbits, if you go to Pastebin, you'll probably find a lot of good examples of what not to do. All right, let's see. So I'm moving right on. Let's start with interactive authentication. This is familiar to you, I'm sure, where you can directly get a PS credential object with get credential. You get the traditional dialog that you can customize to a greater or lesser degree. Enter admin credentials, as you see. And then once we have that PS credential object, we can use it with several commands, like invoke command, for instance, as you see at the bottom of the slide. Easy peasy, lemon squeezy, I think, as they say. Another interactive option, if you're using the Azure cloud, you're probably familiar with the Azure RM modules and the Connect Azure RM account commandlet. Here we're going to be prompted for, it could be a Microsoft account, it could be an Azure Active Directory identity, but of course the chief weakness to this and the get credential is that somebody has to be there to feed that credential in. There's really not a lot of automation possibilities there. So we get into option 2, which is various ways to save your password in an encrypted file. Now, all of these are going to rely, the following examples are going to rely upon Windows Credential Manager and what's called the Data Protection API, or DPAPI, as I like to call it. You're familiar with CredMan or Credential Manager? It's been in Windows for, I think, since Windows 7, but I could be wrong about this. This screenshot shows you the Credential Manager control panel in Windows 10. And this is where Windows stores any credential that you tick the little box to save, whether it's a web credential in Edge or Internet Explorer, or if it's through, mapping a network drive or whatever, Windows credentials. Now, with all this security stuff, we could go down the rabbit hole. I'm not focused, well, actually, it's not my specialty to really go too deep with the security algorithms and this and that, but some might nitpick and say, well, Credential Manager has flaws and weaknesses. The security would assume that every process on your computer is whitelisted. And that would be a fun separate discussion. Have any of you played with any of the Windows 10 whitelisting tools, like Device Guard, and I know AppLocker's been around for a long time, but so that's a point, I guess, that bears mentioning. Any credentials that are encrypted on your machine, we need to trust that the machine is, in fact, clean and not compromised. Actually, instead of just looking at a bunch of slides, let's switch over to my demo environment. And this is that script file that I include in the session materials, and it's just going to walk through a number of points to ponder, I think. I hope that, above all else, I hope that you walk away from this session with some additional food for thought, some ideas, maybe some products, some techniques that you didn't have prior to the session. And actually, I included this code here, just FYI, because I find in my travels that not a whole lot of people seem to either know about or use group managed service accounts, GMSAs as they're called. Are you familiar with those? Anybody relying on these for password management of your service account identities?
Not yet.
Yeah,
Yeah.
I'm aware of them, but I haven't used them yet.
That's what I hear from most of my consulting clients, actually. There's the standalone MSAs when they were originally rolled out, I think in Windows Server 2008. But the group are the really useful ones because these are the ones that can be shared among multiple servers. So here, this is, of course, service account security. I thought it was somewhat related and kind of useful. I just quickly want to walk you through how to use a group managed service account, just FYI. The idea with these is that Windows is going to manage the password. The passwords are evidently super, super strong and long, and they're rotated every 30 days, and they're not going to get, the accounts aren't going to get affected by your domain password policy. The other benefit that these give you is the in Kerberos, the service principal name identities. It simplifies their use as well. So in 19, 20, and 21, I'm just creating a name and the FQDN and SPN addresses. The first time you do this in your domain, you'll have to run add KDS root key. And this just simply gives Windows the ability to auto-generate the passwords. And the fact that we're doing get date minus 10 hours is a hack, because when you normally run this commandlet, you have to wait 10 hours before the Windows will start auto-generating passwords. And this kind of fast forwards, I guess, wait a minute, add hours minus 10. Yeah, so it would be like the 10 hours has already elapsed once you run this command. Then to create the managed service account, as you see, it's new AD service account. And the key part here is with group managed service accounts, the group doesn't refer to an Active Directory user group. It actually refers to the servers that can use that managed service account. And you can create a custom group in PowerShell, or you can use an existing one like here, domain controllers, and just pass in the appropriate names and so forth. That creates the identity, and you can see the identity in Active Directory Administrative Center. The managed service accounts don't show up in ADAC, Active Directory Users and Computers. Then you're almost finished. Then on each server where you want to use the service account, you need to install the service account using install AD service account. And there's even a commandlet to test pass fail whether it's been installed. And then from there you can attach the man. Yeah.
Is there a commensurate get for that? Can you do get AD service account so you can see if there's already one there?
Programmatically. You can do it graphically with Active Directory Administrative Center. Let's see here. Yeah, get AD service account, as you would expect. All of these commandlets are in the Active Directory module, as you can see. This code here on lines 33 to 35 simply walk you through how to bind a group managed service account to a service. So as you see, we're using, well, I should have changed this to get sim instance, but you have to dip into WMI/sim, and it looks like we're enumerating a particular service here that's in this variable. And then using that really wacky WMI syntax, it looks like we're calling the change method. And it's all nulls except for this field here where you specify the name of your GMSA. And note that the group managed service account identities always have a $sign at the end of their name. Okay, so that's just a little extra quickie I wanted to throw in. Those can be awfully useful because as we all would agree, I would hope that service accounts need to be minimally privileged, not domain administrator. And it's nice that Windows handles those passwords. But back to our regularly scheduled program. Oh, there's one more bit here. I was thinking the other day, of ways to use PowerShell to identify your service accounts. I wondered if you queried Active Directory and looked for all accounts that were granted the log on as a service user right, if that would help. If you're thinking of services, that's what line 39 does. This would simply run through whatever your computer name list is and then just look for the services as well as their start name. The start name property is the money here because that gives you the identity under which the service is running. So as you see here, here's my service names and here's the identity. And by default, as you know, a lot of times it's just a local system or network identity. But anyway, now it's time to go back to our regularly scheduled programming, unless anybody has any other questions related to the MSAs. Okay, well, that general theme is going to come as we work through this demo file, that theme of least privileged security and trying to bind an unprivileged service account to a privileged credential for use in a PowerShell script. This was that code I showed in the first slide where we're hand coding. Probably no need to run this. Well, what the heck, why don't we? It's all live. What we have in my environment, by the way, are 2 Windows Server 2016 servers. They're running in Azure. We're locally on server 2, which is a member server. And yeah, it's a member server. And server 1 is a domain controller. So I have an account, an administrative identity called Kyle here, and obviously password 1 is his password. And we can create our PS credential object, build the PS credential, passing in the username and the secure string for the password. And then our invoke command should run just fine. I'm just doing hello world, basically. I'm getting the spooler service on that remote machine. Okay, an old approach. Okay, so here's the interactive method that I showed before, where we're simply doing a read host or just a call to get credential. Well, it's not read host, it's a call to get credential to get the PS credential object directly, and then using an invoke command. I'm sure yawn, no surprises there, but hopefully we can start to get to some little more novel stuff perhaps. How about ways to store the password as encrypted text so that you can simply read back the file from your administrative workstation when you need to run it, or your script can read that file from the file system or potentially a network share. Now that actually presents a little bit of a problem, as you're going to see in just a moment. So it looks like here we're going to do a read host to ask for the password. I'm going to put Kyle's password into that variable now, password 1. And then we can create another variable called secure string text that does convert from secure string. Oh, I forgot to mention that read host has this really nice switch parameter where you can take the input and immediately create a secure string from it. And then if we're converting from secure string, we can take that data that's in memory now and pack it into a simple text file. That's what I'm doing on line 59. And if I bring that Kyle.txt file up into a separate ISE tab, you see it's just, I think it's represented as base 64 text, but it's munged. It's not something that's human readable. Now, the problem here, one problem is that this file is not portable. And the reason for that is when Windows does a secure string encryption, it's using that data protection API, and it actually uses the currently logged on user and or the host name of your system that you're on. I think it uses it to add entropy or salt to the encryption. So as long as you actually not only have to be on that machine, but you have to be logged on with the same identity or have this run space running. Well, actually, I don't even think the run space thing would work. I think you actually have to be logged onto the machine with that account in order for Windows to retrieve the decryption key, unfortunately. So let's see. Here in this bit here, we're bringing the user in plain text. We're bringing the password back as secure string by just doing a get content on that Kyle.txt file. Let me quickly do a password text get member to see what type we're dealing with here. Yeah, well, it looks like it's a system string. Oh, we haven't converted it to secure string yet. Here we go. On 65, we can run that text into the convert to secure string commandlet. And then on 66, we're building an object, a PS credential object, using new object. And then for the argument list, the plain text user and the password. Now, I want to halt here for a minute to ask you a question. In preparing this for you, it's like, why do we all assume that it's okay to reveal the user account name? You know what I'm saying? For some reason, in all of this code that I've researched and asked about and generated and blah, 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 we assume that it's okay to reveal the username. Wouldn't the username, shouldn't that be encrypted as well? Do any of you have any thoughts strongly either way on that idea? I mean, because you're giving a malicious user 50% of the way in if they have a valid username, right? Does that sound logical?
Yeah, and it makes it easy for phishing. That's that.
Oh, yeah, definitely. Yeah, if you have an idea of a naming convention, if it's a user principal name that looks like an email address or just an NT name, definitely. So I just wanted to put that out there. It's something to think about. Instead of just assuming that the username is okay, to consider encrypting that as well. So once we've built up that credential object, we see on line 69, again, the same hello world code that works just fine. Now, my friend...
Will it take an encrypted value for the user in that credential object?
I don't think so, because PS credential, I looked at the MSDN page, and the data type for username is string. So I don't think so.
You'd have to decrypt it with some salt then if you're going to encrypt it, right?
Yeah.
You gotta write something quickly, sorry.
Nope, it didn't like that. Input string is not in a correct format. What?
Oh, cool.
Yeah, not specified. Yeah, so this is, again, it's something I mentioned for you for research, and I need to look into that more deeply myself. Interesting. Now, these next two formats come to us courtesy of Jeff Hicks, my previously mentioned big boy pants suggester. CliXML and JSON are a couple other alternatives. CliXML is a nice way to look at with PowerShell remoting, for instance, your data is serialized and deserialized to and from XML. So what are we doing in this code? Well, first, it looks like we're creating our secure string of the raw password. Here on 74, we're building the PS credential with the username and the secure string. And in 75, we're exporting this as Kyle.xml. And again, let's load this into a separate tab. And sure enough, it is XML. It looks like there's an element called username and password. And I think is Unicode, if memory serves. And then blah, blah, blah. There's the munged string. Same issue with portability here because of the data protection API. When we want to decrypt that password, we'll do an import CliXML and store that in a variable. And let's see, $in.get type. Whoops, I forgot a closing parentheses. Yeah, it's credential. Yeah, so it looks like we're ready to go. We're able to get both the username and the password, parse that from the XML, reconstitute the PS credential, and then away we go on line 81 with our test code. So that's kind of nice. That's a little cleaner than the text file. How about JavaScript object notation? What's going on with that? This looks a little bit nastier, doesn't it? Looks like we're creating a variable from and express. It's kind of complex, isn't it? We've got a username property, and then the password. Where is this stuff coming from? Jeez. Oh, it's starting with the credential object. I see what we're doing now. And then we're selecting out two properties. Okay. And then what's the second one here going? Is that the same code? No, it isn't. I don't think we need line 85, actually. It's redundant. I should have snipped that out. So we're taking that credential object, selecting out username, and then password convert from secure string, convert to JSON, and then simply outfiling that into a .json file appropriately enough called kyle.json. Let's pop this into a separate tab. And the only elements in this file are username with an escaped backslash and our munged password. For decryption, we're going to get the content from the JSON file, convert from JSON. We're going to do a convert to secure string in.password error action stop. Okay. And then finally, building the PS credential object using the secure string password and just the raw username property from the input. Okay. So those are various options that, depending upon your comfortability and use case, may have advantages or disadvantages. They all use the same encryption decryption engine. They all have the disadvantage of not being portable. Questions, comments, concerns? Have any of you used this method of storing the password in an encrypted file? And if so, how has it worked for you?
I have.
You have? Could you tell us more about it?
Because it's not portable, you have to, if you're going to use it with a service account, you actually have to log in as that account once.
Right.
And export it so that the keys will match.
Right. Yeah. But then after that, as long as you trust the file and where it's resident, problem solved?
Yeah, pretty much. It does real well for that type of thing. You have to just do it once and forget it.
Yep. Now, let me see here. Let me clear the screen down below and run line 99. If we look at the syntax for convert to secure string, notice that we have a key option here. Actually, there's a couple options. There's secure key and key. So in answer to the question, can we store our password in a file and put that file on a network share and maybe UNC to it or whatever? The answer to that is yes. The key parameter takes a byte array. So this would be the file option. And that's what we can do next here. It looks like we're going to, on line 101, we can pull the password from get credential as convert from secure string and take that output and put it into Kyle2 text. How is that different from what we were doing? No, I think that's redundant code. Sorry about that. Got a little cruft left in the file. Let's look at 109. Looks like we're going to create the key. There's some options here. 32 bytes is equivalent to 256 bits. If you don't want to use that long of an encryption key, it uses the advanced encryption standard when you do it this way. And 32 bytes, as I said, is AES 256. So we're creating the key here on line 109. And in both of these. And then we can, on line 111, create the file. So that's just simply a symmetric key used for encryption and decryption. Obviously, you'd want to keep that key as secure as you can. And it's, just a column of numbers. Let's see. What are we doing with the key? It looks like on line 115, we can get credential and pull the password, convert from secure string key, get content, path AES key, and then set the content in our out file. So it looks like this pipeline is going to take the password encrypt it with your AES key, and then store the encrypted password here. Now, then we could there take Kyle3.txt and our AES.key and feasibly put them wherever we want them to be. To retrieve the password on line 117, we start by getting the content from the text file and then running a convert to secure string with the contents of the key. Pretty straightforward, I think. And then as all of these patterns have been building up to, we create the PS credential object, supplying the plain string for the user and the credential for the key, and then boom, pop it into invoke command. And Bob's your uncle, as the Australians say. All right, onward and upward. Let's see if we catch up with the slides, see if there's anything.
Sorry to be a pest, but I have another question.
Please do. If I can answer it, I will.
Do you happen to know if that works with PowerShell 6 and using it? Something you could move over portably to Linux if you need to?
Good question. No, I don't know offhand. Let me make a note of that so I can find out tomorrow and let you know. Good question. Can we do these?
Tim, I'll actually try it out. I have a Ubuntu box. I'll try it out tomorrow if I get a chance.
Okay. Yeah, I haven't done any of this on PS Core. It's a brilliant idea. I wish I had thought of it. Okay. Crypto PS Core. Okay. I understand Joel Bennett spoke for you last month, and I'm referencing one of his projects right here. He wrote a wrapper to the Windows Credential Manager in a module called Better Credentials. And it's just meant to be an interface, a way to retrieve Credential Manager entries, store them, and that's really essentially what it is. There's also Dave Wyatt's Protected Data module. And this is very analogous to some commandlets that are actually part of PowerShell 5 and 6 that deal with the ability to encrypt. You know, you can encrypt certificates, you can encrypt files, you can encrypt raw data. And this is just an alternative to using the native commands that are in PS5 and PS6. We can look at those next in the script file. Okay, so first, of course, we can grab the Better Credentials module from the PS gallery. I already have it installed. It's important to include the allow clobber switch parameter because what he does in the source code here is he rewrites get credential. So when you want to use his version of get credential as opposed to the one that's natively in PowerShell, you'll want to call Better Credentials / get credential. So for instance, here we can use the normal get credential, company, tile, and password. And then calling his get credential, I guess we could have done this line 127 using his code as well, but whatever. And we can take that credential and pack it into the Windows Credential Manager store on this computer with there. And then when it comes time to retrieve that credential in our code, we can, as line 131 shows, in a variable just call Better Credentials get credential by username, you know, get help to look at all of the ways to pull the data, but if you know the username, it's easy, easy to do it that way. And then at that point, I'm sure that BE cred is, of course, a PS credential object, so we can pop that into our code. Right, so I thought that was an appropriate and timely module to share with you. Regarding the protected data, I learned a lot from Dave Wyatt's, I think it was PowerShell Summit in 2015. He did a whole lesson on what we're talking about, really. So I'd encourage you to look up his session on YouTube. And he goes over the use of this module a bit. So some of this code directly comes from him, at least in large part. And as I said, his project kind of duplicates some of the functionality that's in the built-in CMS message commandlets. I think CMS stands for cryptographic message something. I forgot what the S stands. But the built-in command's pretty straightforward. There's a get, protect, and unprotect. And the way it would work is something like this. We can create, or using your PKI or using new self-signed certificate, we can create an EFS, an encrypting file system certificate, and store it in our local store. And then if we want to use that certificate to encrypt a password, let's say, which I have here on line 145, we can first obtain the thumbprint of the encryption certificate on line 147, and then call protect CMS message. Whoops, cannot find argument 2 because it's null. Didn't think it was null. The thumbprint's wrong here. The thumbprint would be, let's scroll up here, right here. Whoops. Let me paste that in. There we go. Now we should be able to protect that message. And it's just munged. So it's pretty clean. I mean, how do you all feel about certificates? Remember earlier I asked what you thought about group managed service accounts, and you're like, well, it's on our to-do list. Do you feel the same way about PKI, or are you using, say, Active Directory certificate services internally? Anyone? Bueller? What do you think of PKI? Is it worth it? Is it worth the maintenance and upkeep?
Just wish there's more information. I always find it hard to find any information on it.
Related question. Are any of you using PowerShell to sign your code, to sign your scripts? And
Just started.
Oh, good. I'm glad to hear that. You know, if you use PowerShell Studio, the Sapien tool, they automate it where they'll automatically slam dunk, they'll sign your scripts and put the block in there for you, which is a really nice convenience I found.
Nice.
So let's see. So that's protect CMS message. So those are the built-in commands. And again, long story short here, the idea is you can use those commands to quickly and easily, say, use a certificate to encrypt and decrypt a password in your code. And unprotect, it's the same thing, really clean. That CMS object, that encrypted credential we have here, we could just bring that into unprotect CMS message and then decrypt it. So that's what you would use on the other side to reveal the credential. Let's see, I don't think I've installed Dave's module from the gallery. So as you see on line 156, you can make a call out and grab protected data. Once, if and when that happens, we can run a get command and look at the commands. There we go. So let's quickly install this.
With the credential store that's on Windows, do you have to worry about it? It's tied to being a single user, or is that distributed across everybody on that machine?
That also is per user. That DPAPI, it stores its data under app data, blah, blah, blah. There's a path. If you look up DPAPI MSDN page, it tells you it's per user profile. It's part of the user profile. So let's do a get command from that module. And, you know, let's see. Protect data, unprotect data. Those are the two main ones here. So if we look at protect data syntax, Dave, you know, being a good PowerSheller, to say the least, he wrote it to accept an input object, which makes it easy to feed data into this commandlet using the PowerShell pipeline. And let's see, anything else that pops up here? You could encrypt using a password, a secure string, or a certificate. He has both of those here. Let's see. I don't think I should need to do another cred get credential. I think I still have the Kyle one there, so I'll ignore line 162. But notice on 164, the way you would encrypt, well here, what are we doing? We're taking a credential and we're encrypting it using a certificate. That seems a little redundant to encrypt something that's already encrypted. But the main workflow here, as you see on 164, is whatever it is that you want to encrypt, you can use the pipeline here to pass it into protect data, and then using either a password or a certificate if you have a reference to one. Let's see. Yeah, okay. And the same thing with unprotect data. What's been encrypted, you just pass it into unprotect data to get back the raw text. Okay, so I think I understand what Dave was doing here. So he was encrypting the credential, and then he was encrypting the PS credential object, and then decrypting it, and then once it's back in its native form, passing it into invoke command. That's interesting. That sounds like, if I'm thinking of this correctly, if I'm understanding this code correctly, that might answer that question earlier about protecting both the username as well as the password portion of the credential. I don't know, just thinking out loud for a moment.
It's an onion.
Yeah, it really is, isn't it? Peeling away the proverbial layers of the onion. How are we doing on time? Looks like we're okay. So option 4, this is the most complex, but I think it's the most I think it's the most forward-thinking option. I mean, there's that old saw that the best password is the one that you don't even know yourself. Some popular credential vaults: AWS Key Management Service if you're using Amazon, Microsoft Azure has Key Vault. There's LastPass Enterprise, there's Psychotic Secret Server, there's SpecOps Password, there's HashiCorp Vault, Dashlane, Password State. These were the major ones I was finding. Anybody else have any other entries that you want to add?
CyberArk, does that count?
What is it called?
CyberArk.
CyberArk. I've never heard of that one. Thank you. Thank you. All of these that we see here, I'm not 100% sure actually about Password State, but I think these are all closed source proprietary. Just before we were getting started, I was doing some furious searching on my phone, looking for free and open source credential vaults. And the best I could find were some quote unquote password managers, which I'm not sure how enterprise ready they are, but KeyPass, if you're familiar with that, is free and open source. Padlock is another I found, Passbolt. So have any of you bought into, pun intended, a credential vault, either personally or in business or in both?
Both.
Both. I'm glad to hear that. Yeah, I mean, come on. I mean, ideally, it's best to have a different password for each service. I mean, personally, for years, I used LastPass, but then with their breaches, number 1, and number 2, the clunkiness of the UI, I finally went over to 1Password, and I've absolutely loved that. And as far as two-factor, I know that's not really in scope with what we're doing tonight, but I would suggest if you haven't settled on a two-factor app, an authenticator app, Authy, A-U-T-H-Y, I'll tell you why I think it's much better than all of the alternatives, Google Authenticator, Microsoft Authenticator, you name it, is the Authy is the only multi-factor tool I know that actually you can share the same account across multiple devices. So you don't have that single point of failure. Because I've been burned having an authenticator app where my phone, I forgot what happened, it wiped or whatever, but I lost it. And then I had to scramble to try to redo the multi-factor. It was a mess. But Authy, I mean, it's got a browser extension. It's on your phone. It's really great. Anyway, this slide, I was doing some crowdsourcing and preparing this presentation for you. And if you know Brandon Olin, his Twitter handle is DevBlackOps. He has some really interesting stuff going on in his business using credential vaults and least privileged security along with PowerShell to automate all of the stuff we've been talking about thus far. So I put what he said as best as I could into a Visio drawing. That's what you're looking at right now. So we have the credential vault, whatever it is that you're using, storing a privileged credential that you need ultimately in your automation script file. You have a certificate server. Alternatively, you could use a self-signed, of course, but best practice, you have an honest-to-goodness PKI where you have the ability to generate an encryption certificate. And then if you're in a domain environment, you have your domain controllers, and you have, as I said, a service account with low privilege. And the goal is to give this low privilege service account an EFS encryption certificate, and encrypting that privileged credential coming out of the Credential Vault, and then that encrypted credential being decrypted in your automation script file. You'll have to talk to Brandon, hit him up on Twitter, or if you have another method. I asked him, and he's really into the idea of sharing more detail about his workflow here, and I hope that he does do those blog posts, because I'm really curious to know in more detail. But the high-level thing, the high-level takeaway would be, as long as you have application programming interface or API access into your Credential Vault, you should, hopefully, in quotes, be able to pull out a PS credential object. And then from there, it's just, I mean, he involves a separate low privileged service account. But the theme here is, how can we programmatically tap our Credential Vault for credentials and make sure that the identity under that the script is running under doesn't need to have access to the credential directly. Hope that made some semblance of sense. I have some code here starting on line 177 where I walk through a representative implementation of that using Azure Key Vault. I've already authenticated into my Azure subscription, at least I hope I have. Let me do a quick Azure RM context. Okay, I guess I'm going to need to quickly authenticate here using an interactive method. But while that's cooking, you can see I'm creating a resource group, which, well, I mean, let me ask you directly. Are any of you using Azure for production services right now, or is this a bad example across the board?
We're starting to use it over APS.
Okay. Well, the underlying principle really is irrespective of the credential vault. We'll need to authenticate to the vault and use some kind of method, whether it's PowerShell or direct, HTTPS REST calls, whatever it is, to be able to pluck credentials from that vault. Let me type my password here. Okay.
Okay, say your password out loud so you can just type it
fast. Okay, so here we are with the two-factor, so I'm going to quickly pop that in. 191.928. Boy, the two-factor really saves my bacon with Azure, because in my work for Pluralsight, my training goes all over the world, and probably not be surprised to learn that my subscription gets hammered every day by students who see my demos and think, oh, okay, I see that Tim's Microsoft ID is Timothy Warner's 316 at Gmail. So why don't I see if he still has those VMs running? Oh, brother. It reminds me of remember the dude who, I don't know if he formed the company or if he was just the spokesperson for that identity theft service. Remember, he put his social security number all over their ads, and then he got totally owned by somebody. They stole his identity and charged a whole bunch of stuff. Okay, so let's see here. New resource group. I'm just going to quickly clicky through this. The resource group is simply a container for related resources. To create a key vault is just a simple command here where you give it a name, a resource group, and an Azure region. Whoops, it's already in use. Okay, I'm going to make it unique here. And then we have our secret, in this case, a password that we want to store in that vault. I guess we're going through the workflow from front to back here. We're going to create a secure string out of it, and then we're going to just call, whatever API command, whatever PowerShell that's linked to that API in your Credential Vault. In Azure PowerShell, it's set Azure Key Vault secret. Give it a name. The secret value is the secure string. You then, with Key Vault, you need to do a little bit with permissions. You could do this in the Azure portal if you didn't want to do it with PowerShell, but basically, you're giving an Azure identity the ability to decrypt and get and sign secrets from that security vault. I don't want to go too far down the rabbit hole with service principal names in Azure and all that garbage. Just basically, you're adjusting the permissions so that your script can get the credentials out. And then get Azure Key Vault secret allows you to pluck the secret. And then what are we doing here? We're pulling the actual secret value, which is the password. And then we're going to build a credential object using that secure string. So it seems to me that any of the major credential vaults are going to allow you to pull either a full-fledged PS credential or at the very least a secure string that you can use to build a PS credential. And then, away you go. Okay. All right. Not sure if we want to. Okay, I'll mention one more thing about Azure, because this again is applicable to other cloud platforms as well. This here on line 207, this code block is useful in the case where you have, say, a PowerShell script that's going to run against Azure resources, but you don't want to do that interactive step, the connect Azure RM account. What you have to do an automated Azure authentication is create basically a service account. It's called a service principal in Azure. It's not a user account. It's confusingly called an application registration. I can't stand that name because it's really kind of misleading. But what we're doing in this code is creating a self-signed certificate and then a service identity in Azure using that uses that certificate for authentication, because obviously we're not going to use a password. We want it to be an automated authentication. And then you give that service account identity in Azure some level of permissions. Here it looks like we're giving the account contributor, which is basically read-write access at whatever scope you're using, subscription, resource group, whatever. You need to get the Azure AD tenant ID. You need to get a reference to that service account, what's called the application ID, confusingly. We need the thumbprint of that service account's certificate. And then when you run connect Azure RM account, instead of providing a Microsoft account name and a password or an Azure AD user account and password, you use the service principal switch parameter. And you need to pop in the certificate thumbprint, the service account ID, the Azure Active Directory tenant ID, and there you go. So that's a pretty nice way to automate authentication. And once you're authenticated, any additional commands that you run are going to run under the context of that service account. Pretty neat. And Azure Automation simply extends upon that idea. If you've never used Azure Automation, it's simply a hosted platform for running PowerShell and or Python scripts, either on a schedule or ad hoc. It's up to you whether you want to know more about that. It's totally up to you. Either that or we can draw things to a graceful close. Questions, comments, concerns? What do you have for me? What else would you like to know? Nothing?
Where are you going?
I got a question on the certificates.
Okay.
So if you sign your script with a non-self-signed certificate,
yeah,
I assume the user or computer running the script has to have the full cert chain, or how is it secure? I guess.
Certificate validity checking.
Do you know how it works at all, or who has the private key, or is the private key stored within the script, or how?
You always keep your private key. If you do self-signing certificates, you start an architecture, something like Web of Trust, or something, where you start saying, well, here's some people I trust, and you start building. What's interesting is to watch the technology that's putting it all in blockchains, but that's a different story altogether.
Yeah.
So, excuse me for jumping in. But.
No, I appreciate that. The blockchain thing is a total dark art for me. I'm not sure what to think of it.
Oh, you have to look at this, because blockchains can encrypt, or not encrypt, but can make any document you put in there, they protect the integrity of any document. It can't protect the actuality, but it can protect the integrity. Of course, if you encrypt something, you protect the integrity of that encrypted piece. But you can do legal documents, you can do any type of things, but authentication and authorization in blockchains where you don't have a centrally managed certificate authority and those types of things is the future. That's the digital transformation.
Is this blockchain the one where it grabs a packet, encrypts it, grabs another packet, encrypts it based on the hash of the previous one?
Basically, yeah, you have to do data mining, and these are the data miners that actually run the algorithms to authenticate that is in fact that transaction is in fact valid. Said a number of things, but then once it's been validated by data miners, it becomes a part of the chain.
Okay, no, yeah, you took on.
I'm sorry, I'm bringing you off subject here. I don't mean.
No, I want to thank you because you've successfully piqued my interest about blockchain. I've had pun intended, I've had a block about blockchain. Really quick, funny story, although it's tragic more than funny. About 5 or 6 years ago, I worked for a company where the CEO was just nuts about Bitcoin. He invested well over $1 million building a bunch of miners. Like he rented data center space. I don't know how many racks of high performance machines that did Bitcoin mining. And he was really generous. And when I left that company, I had 30 something Bitcoin. And I really just thought I was kind of over it after hearing so much about it. And Bitcoin was probably worth 100 or so per coin. And so I sold them off gradually over the course of a couple of years. And I thought, I wonder if I'm going to regret this someday. So my Bitcoin balance went down to zero. And then, as you know, a few months ago, they hit 20,000 bucks. I would have had nearly $1 million if I had held on to those Bitcoin. So for that reason, you know, the Aesop's fable about the fox and the grapes, I've had a little bit of sour grapes about anything that, that touches on cryptocurrency. But I think you've gotten me past that a bit, because I think, like you said, there is obviously more to this blockchain thing.
Yeah.
Okay.
If you send me an email, I can give you a little bit of background info on that.
Thank you. I will. I'll add email to the last slide. This is the second to last slide. What I think what I intended the take-home themes to be were for you to consider group managed service accounts if you haven't before. Think more about the certificates, and to the person who asked the question about the certificate validation, I don't know enough to give you a more detailed answer. I'm sorry about that. But think about PKI and think about blockchain. I'm thinking about it. And also the issue of integrity with PowerShell scripts, PowerShell code signing. And then finally, keeping in mind password vaults and that old saw that the most secure passwords are the ones that you don't know yourself. I mean, that's something I remember when I did more desktop support a long time ago. Helping a user, they're more than willing to give me their password. It's like, wait a minute, no, I don't think you understand. I don't want your password. I really don't. Don't give me your password. I don't want to know it. I don't need to know it. Call it plausible deniability. Call it what you want. So here's my contact info. I'll pop up my email address here. Let me pop out into the behind the curtain, so to speak. Yeah, so again, the materials are at timw.info, AZPosh1. Twitter, Tech Trainer Tim. I post a lot of tech news every day, so my account might be good for you to follow for relate PowerShell, data center management, Azure kind of stuff. LinkedIn, web, and then email down at the bottom. That's about all I have. I'm kind of tapped out. Thanks very much for having me, everybody. I really appreciate it. I hope that you got a lot out of this.
Timothy, before you go, can I ask a few questions, or do we have time?
Oh, yeah, definitely. I do have time. Go right ahead.
Is there any way to do anything other than two-factor authentication in PowerShell? Have you looked into that at all?
What would be an example?
Well, you know,
biometric?
You've got so many devices. Yeah, well, the two-factor authentication is just your username and password, whereas you also have, you know, that's something you know. Something you have is like a CAC card or
right.
And something you are is your thumbprint that a lot of phones are looking at now, or you know, retinal scans and all the other The thumbprint and facial recognition are the big pieces that are coming into the phones.
Yeah, for sure. This laptop that I'm on right now has a fingerprint reader, and it has the Windows Hello support built into the webcam, the facial recognition, what you said.
Yeah, those boil down to just a few, you know, very small set of data.
You know something? I not only haven't used biometric with PowerShell, I've never once seen it implemented. Has anybody seen that? That's actually a really thought-provoking question.
It would have to be an API that looks into a black box, because you can't have the biometric data in the open. Each biometric would have to be uniquely done by the chipset. I know Apple themselves hides that biometric data, because otherwise it's easily dispersible and can be violated and used elsewhere.
Yeah, that's a very good point. Wow. Yeah, because that is ultra personally identifiable information. I mean, the geography of your face, your retina, your fingerprint.
Hell, with 3D printers, you could take any face and make it into masks.
Are you running the script yourself for the where you want two-factor?
I haven't run a script in forever. That's why I'm here. I don't know.
I don't know anything like boxed or canned within PowerShell, but you can. I did this for a work exercise where, like, within your script, you can generate a code and just email it to somebody. So before the script, and then you can write the script to where the script will continue unless you get that exact code into it. So something similar to that. Yeah.
That's just like a pass-through code.
Yeah, I know with Azure CLI, for instance, the way you authenticate to that, and if you don't know, Azure CLI is a Python cross-platform scripting tool for Azure. And to authenticate there, they force you to go out to a web page to get a one-time code, and then you paste it into your console session. So at the very least, it seems to me the one-time password thing seems like it would work with PowerShell. That's some more food for thought. I'm going to look into that deeper tonight. It's interesting. Anything else?
Yeah, I got a question on the password thing. Have you used any of like the vaults or anything like that you mentioned in your PowerShell scripts? Do you have them set up at all? Or like what is we're doing something similar with Chef.
Yeah.
Ruby, and it's real. Like I'm having a hard time like trying to splat the password in. Like it doesn't work exactly like the KeyPass vaults or password vaults. But I'm having a real hard time trying to like splat passwords in, like like PowerShell scripts or text files or how do you use it per se if you use like a password vault?
Well, I'm not the best person to ask because I'm a one-person operation. So I use 1Password, and they have limited API access, and I have a PowerShell front end to 1Password. In fact, I would encourage you to go to GitHub. I know we talked a little bit about GitHub earlier, and see if somebody has written an easier to use interface into your Credential Vault API. What I do with my consultancy, of course, a lot of my clients will use the password vault, but I won't have access to the innards for security reasons. So I haven't had need really to deep dive. I will say that it seems like the majority of the PowerShellers that I deal with prefer either Azure Key Vault if they're in Azure, or if they're not, a product called Thycotic Secret Server. That company has evidently really gone all in to try to make their product as easy to use as possible with PowerShell. So I just offer that as a suggestion, something to think about. By the way, I don't have any affiliate relationship with any of those companies.
Thanks.
Cool. Have you seen anybody use OAuth in for PowerShell scripting? Ping comes to mind. I mean, do we have any? Sorry, I'm coming out of this out of the blue. It just suddenly dawned on me. Maybe ping services or something like Google or Facebook through OAuth authentication would be another form of authentication, credential authentication that we could use.
You're thinking of like the single sign-on tokens, the SAML and OAuth tokens. I mean, it's got to be that way. I mean, because when I authenticated to Azure a moment ago, I supplied a Gmail account, and that used OAuth and OpenID Connect, perhaps, to do federated identity.
Yeah, of course you did. Yeah. I was just wondering if there's any good modules you know of that could do that. We could use for that purpose.
Not that I can think of offhand, sadly.
Yeah, OAuth is an authorization. It's not an identity.
Yeah, the identity is
right,
third party.
Exactly.
Yep.
I wonder if the answer to your question that you posed is something that hasn't got something to do with the API that you're using to get in, and maybe Open API is something you should look at. I don't know. Yeah. Just an idea. Throw that out there.
So I put a link into the Windows Hello API, kind of like a starter for somebody that was a C# developer. That you could actually pull those DLLs in and then start operating on those to kind of get you part of the way there, I would think.
Well, Timothy, I sure appreciate your presentation today.
You're welcome. I appreciate you all having me. It was fun. It was cool.
I got your email, so I'll send you the blockchain stuff I was talking about.
Thanks. Thanks a lot. All right. Let me see. Let me stop my sharing. And I'm about ready to turn into a pumpkin. I better go off to bed. Catch you later, guys.
Well,
have a good one.
We really do appreciate it, Tim.
You're welcome. Anytime. Take good care.
Thank you.
All right.
Thanks.
Okay. Wow, that was quick. All right, Tom, any good news? You have the whole YouTube.
You want to stop the broadcast?
Yeah, well, I wanted to know if you want to say anything to the YouTubers out there.
Yeah, we have 7. 7?
Yeah, we have 7 viewers, yeah.
Not at this point. I think we're good to go. I don't think we had any questions, did we?
No, just mostly David Kodzilis saying a few things. Jeez, I'm sorry I butchered your name. All right. Thank you for watching. See you next month.